Hello, and welcome to this lecture series of normalization. In this lecture series, we'll be talking what normalization is and some real world scenarios and examples of achieving the different normal forms. So, by definition, a normalization is a process in database design that helps to eliminate redundancy, improve data consistency by organizing the data into separate tables based on their relationships. In simpler terms, a normalization process involves creating tables with specific structure that meets the certain criteria called as normal forms. By applying normalization techniques, databases become more efficient, easier to maintain, and less prone to data anomalies. So, what are the goals of normalization? Like I said, eliminating data redundancy is the very first goal. Redundancy means unnecessary duplication of data, and redundant data increases storage requirements. Normalization helps to eliminate these redundancies by dividing data into smaller independent tables. Second is minimize data modification anomalies. So anomalies occur when making changes to the data, such as insert, delete, or update operations that result in inconsistencies or incorrect data. Normalization helps to reduce such anomalies by properly structuring the database. Third is improving data integrity. Data integrity ensures that the data in the database is accurate, consistent, and reliable. By organizing the data into well-defined tables and applying normalization rules, data integrity can be improved. And if options 1 and 2 are met, we can naturally improve the data integrity. So let's discuss the anomalies in a non-normalized model in detail. The very first is insertion anomaly. Not able to insert all the required data because of missing values in some columns is the simple definition of an insertion anomaly. Let's take an example here. In this customer's order table, the very first case is the name of the John has been repeated twice, and the customer address as well. Say, for example, if John visits the store 1,000 times, I would have to repeat the name of John and the address 1,000 times, which is increasing the redundancy, and it's definitely not a great idea when it comes to storage. Now let's talk about the insertion anomaly. Suppose I have a new customer, Emily, which I acquired, but Emily hasn't placed an order yet. Now, the order ID for Emily will be a null value or not available. Now, if I try to insert this value into this table in the database won't allow that. Why? Because the order ID is null and order ID is a part of primary key. And as a rule, we can't have a null primary key. So I would have to wait until and unless Emily places an order and order ID is attached to it, and then I can insert that record. To remove this insertion anomaly, we can create separate tables and establish a relationship between orders and customers using foreign keys. Let's see how. In this normalized structure, table 1 customer represents the customer information with a unique customer ID for each customer. Table 2 establishes the relationship between orders and customers using the customer ID foreign key. Each order entry now references the corresponding customer using foreign key, eliminating the duplication of customer information. So you see, we just have one instance of John. With this normalization, we can now insert customer orders without any insertion anomalies, as we have a separate table for customers and their information is referenced using foreign keys. So I can insert the value for Emily, and when Emily places the order, I can insert a value in the orders table. Let's talk about the next anomaly, which is update anomaly. So simply, when we update a piece of data in one row, but we forget to update in other rows that contains the same data. For example, we have a table that stores product information and we duplicate the product information in multiple rows. For example, this laptop. This laptop is of vendor V1 and this is product ID 1, product ID 3. These are the two different product IDs, but this laptop should have a same price. Say, for example, if the price revision happens and we update that information into this row, but we forget to update in this row, so there will be naturally a conflict and the data will be inconsistent. So when we are updating a record, we have to update on all the rows where that information is present. This problem can be also resolved by moving these products into a different table and then mapping it to the prices. Next one is deletion anomaly. So simply it means that when we delete a piece of data in one row and information for other attribute is lost. Let's see an example. In this table, we have the information for employees, the departments they are working, and the salary they are drawing. For example, sometime David decides to leave the company, and David is the only person in IT. So we have to delete this information for David, which inadvertently deletes the information for this department also. Since David is the only person working in this department, we'll lose this information, department IT altogether. So the information is lost. The solution to this is that we store the department's information into separate table and then map it to this employee table using a foreign key relationship. So when David leaves, we just delete the information of David and the department IT stays. So let's recap. We dealt about anomalies, which are insert, update, and delete anomaly. And all of these anomalies are arising from redundant or repetitions of data and not breaking the tables apart into different entities. In the next lecture, we'll be talking about the normal forms and the ways we are going to normalize the database. So we'll be starting with first normal form and eventually we'll move higher up towards the fifth normal form.